Hi everyone, welcome back to Geeks for Geeks Practice and welcome back to another problem of the day. So please give me a quick +1 in the chat if my voice is clearly audible to everyone and everything is working fine so that we can get started with the problem as well. Okay, so yes, it just started now only. Okay, hi Shoaib, hi everyone. So please give me a quick +1 in the chat. Naikaj is there, Rishit is also there. So hi everyone, let's get started with the problem solving. So please hit the like button first of all, okay, and then we'll get started with this problem as well. Okay, so please hit the like button first of all so that I can get started with the problem as well. Okay, good morning. Yes, it's a very good morning. Jab jago tab savira, right? So just give me a second, I'll start with this as well. Okay, you can hit the everyone can hit the like button. That is what I'm expecting as minimum, right? I just came back from a live stream only. Where is Abhinav Avasthi? So you can DM him on LinkedIn, right? Then he will tell you where he is. I'm not sure where is he today. I think you can DM him on LinkedIn and ask him. Okay. Now what I'll do is, first of all, I need to open the whiteboard. Okay. So just give me a second. Uh, let's open the whiteboard. Actually, I don't have a proper setup today because my laptop got corrupted. So today my laptop got corrupted. So everything is like nothing is there. Like if you will see, if I'll open this, so actually nothing is there in my drive, this PC and everything. Everything is lost. Nothing is there in the download documents or anything. So it's not a good day so far. So just give me a second. Now what I will do is I'll start writing also. Okay. So this pen is working and I hope others are also working, right? So let me change the color of this pen. All right. So let's get started. Abhinav Avasthi is on thumbnail, so I expected him. If you want, I can go and he can also come. That is fine, right? Let's get started with the problem solving now. Okay. So what's the problem? Let's see what's the problem now. Okay. So the problem is flattening a linked list, right? So flatten a linked list. The problem name is flatten a linked list. Okay. Flatten a linked list. Right. Now, in this particular problem, what we need to do is it has been asked in Amazon, it has been asked in Flipkart, it has been asked in Goldman Sachs, Microsoft, Paytm, PayU, Qualcomm, Snapdeal, and Visa. Okay. If you will see the related courses, so these are the related courses for this problem. Now, in a normal linked list, what happens, right? Can I say this, guys? That in a like for a normal linked list, we have a node. Okay, that node does have some data. Okay, and it has the pointer to the next node, right? Then we have another node, let's say. Okay, this node also has some data, right? And it has the address of the next node, right? Yes or no, guys? Quickly let me know. Is this point clear to everyone? Is it clear to everyone? Okay, I hope that it is clear, right? This is what a normal circumstance in a linked list looks like, right? This is what normal circumstance in linked list looks like. Now, if I'll talk about this thing, right? If I'll talk about this linked list, so you can see that there's one more pointer here, right? There's one more pointer. So you can see that you have been given a linked list, okay, where every node represents a sub-linked list and contains two pointers, right? The next pointer, the pointer to the next node, and a pointer to the bottom node, right? So if you will see here, right? If you will see here, so basically, let's say if there's a linked list one, okay, let's say its next node is two, its next is two, but down here it will also have this guy as five. Let's say down here it will also have this guy as seven. Let's say, right? Is that clear to everyone? Right? Is this point clear to everyone? Like this guy has a like this guy, like if you will see, so this guy has a bottom, right? Five. So basically, this is what has been said, like bottom pointer to the linked list where this node is the head. Okay, so this guy is the head, and this is another linked list down here, right? Is that clear to everyone? Please tell me, guys. If it's clear till now, you can hit the like button, and then I can proceed further with it as well. Okay. So let's have a look at the next example, sample example. Okay, let's have a look at this example, right? So let me draw this example first of all. Let's see what is given, right? So five is given. Okay. Then after five we have 10. Then we have 19. Okay. Then we have something like 28. Okay. So we have five. Then we have 10. We have 19. We have 28. Okay. So if you will see here, we have seven. Okay. Then we have eight. Okay, then we have 30. All right, and here what do we have? We have a 22 and we have a 50 here, like we have 50 here. Okay, now this is what has been given to us, right? This is what has been given, right? This is what is given to us, right? This is the linked list that has been given. Now what do they want? They want us to flatten this linked list, right? So what do they want in the final answer? Let's have a look at it. Okay, let's see what is the final answer that they are expecting. So they are expecting that, okay, what you will do is, if you will see here, like what they are expecting, they are expecting that you'll have 5 7, right? 5 7, 8 10 19, like sorry, 5 7. Okay, then you'll have 8. Okay, so you will have 5 7 8. All right, so the resultant linked list has every node as a single node. This pointer is written representing the bottom one. Okay, so let me see again. Each of the sublinked lists is sorted. Okay, flatten the linked list such that all the nodes maintain the sorted order. All right, all right. So basically, what are these people expecting from us? If you will look at this part, right? So they are expecting that, okay, what will happen is, like this much part, like they are expecting that, okay, if they want a sorted order, so they will first of all want this much part, right? Till this point, 8. So they will want that, okay, you will write 5 in the answer, then 7, then you will have 8. Okay, then after that you will have 10. This guy 10, right? Then you will have this guy 19. Then you'll have 22. Okay, then you'll have this guy 30. Okay, and then you'll have this guy sorry, then you'll have 28, then you'll have 30, and then you'll have 50. Is it clear that they are wanting you to present the final answer in sorted order? Is it clear? Please write sorted in the chat if you are clear till this point. Right, basically what they are expecting from you is, they are going to give you this linked list. Okay, this linked list which has some bottom and the next pointer and everything and stuff. Right, now what they are expecting from you is, they are expecting that, okay, the return, the flattened linked list, the single linked list that you will return, it should be sorted. So basically what will you do? Like basically, if I will talk about this normally, right? So what will you do? Like, can I say that you will take a, first of all, you will do what? Like you will do, take this node 5. Okay, then you will take 10. Okay, then let's say you will, sorry, you will take 5, then you will take 7, then you will take 8, right? Then you will take 10, right? Then you will take let's say 19, then you will take 28, then you will take sorry, 19, then you will take 22, then 28, then 30, then 50, right? So does it not remind me about a little bit about pointers? What do you think? Right, two pointers kind of concept, right? Like I need to see less than, greater than signs, right? Yes or no? Less than, greater than. What do you think, guys? This is the first observation that I'm having in this problem. This is the first observation that I'm having, right? Is that clear? Is that clear to everyone? Is that clear? Right, is that clear to everyone? The first observation that I'm having in this particular problem is that I basically need to do what? Like if I'll have the very first basic observation right here. Okay, so the first and the very basic observation is that I will be having uh 2 point, like I'll be having some pointers, like some pointer sorting related stuff. The first thing. Now can I say that I'm repeating? Like, see, if you will see here, right? Like let's say that if I take this node 5, right? If I take this node let's say 5. Okay, if I take this node 5. Okay, then after that I'm taking this 7, right? So can I say that I'm, please write rep in the chat, right? Can I say that I am repeating a particular process again and again? I don't know, as of now I don't know, but there is some kind of process that is there. Okay, there's some kind of process that is there, and I can for sure say that I'm repeating that process again and again. Yes or no? There's some kind of process which I don't know as of now, but I am repeating that process again and again. Yes or no? For every node one by one throughout the linked list, I'm repeating that. Yes, please write yes in the chat, or please write rep in the chat. Are you clear with this thing? That they will be there, I will establish a particular process, right? For flattening this and merging everything and all, right? But I can say one thing for sure, that I am repeating that process again and again for every stuff, every nodes, right? One by one, one by one, one by one throughout. Correct? So all of you have written repeated. Please hit the like button if you are clear till this point, guys. If everyone is clear till this point, you can hit the like button as well. Okay. So this is what we are trying to do. Okay. Now, if you will see this answer, like let me erase this much part. Okay. Just give me a second. Let's erase all this. Okay. Let's take one simpler linked list. Let's say if I have something like one. Okay, let's see if I have one. Okay, let's say one is connected to something like three. Okay, three is, let's say, connected to something like seven. Let's say this guy is connected. Let's say this guy is connected to, let's say, eight. Okay, let's say this guy is connected to something like five. Okay, if this kind of scenario is there, so can I say that I'll use recursion? If I'm repeating the same process, please write REC in the chat. Right. The first thing that comes to my mind is I'll be using recursion. Correct. I'll be using recursion in this particular case, right? The first thing that comes to my mind is this is like a tree. This is like a tree. You cannot say it is like a tree. Actually, a tree is little bit different. It is not exactly like a tree. Okay, I think you are looking from this direction, so that is why you are thinking that okay, one is there, five is there, three is there, eight is there, seven is there. But actually, this is not the case. Okay, so it does not look like a tree first of all, right? Now, what can be done, right? What can be done here? The next thing is that okay, what can we do? So if we will look at this particular thing here, right? So basically, if you will see, right? So I'll be starting from the like, let's say, guys, understand this thing. Let's say if there is only, let's say if there is no node, okay. If the current route that has been given, like if the current linked list route that has been given, it is null, right? So if there is no node, right? So can I say that I'll return null, right? If like I have to show one thing, I'll show you on the basis of code, okay. Hi, Kulay Balaji. So what I will do is I'll just copy this part. Just give me a second, okay? Just give me a second. I'll show you. I'm using the code as a reference today, okay? Because I think it's very late, so many people might not want me to write the whole code, okay? So let's use my code that I've already written as a reference. Okay. Now see, if the root is null, right? If the root is null, if there is no node, okay. If there is no node, then I'll do what? If there is no node, then I'll return that null. Okay. Could you explain the intuition for this recursion? Yes, I will explain it. I will explain that intuition for the recursion. Just give me a couple of minutes more. Okay. Now, if you have no node, okay, or let's say if you have just one node, okay, if you just have one node. So if you have, let's say, there's no node inside the linked list, or there's only, let's say, one node, right? So in that case, can I say that you will just return that root node of the linked list? Yes or no, guys? Please tell me. Is this point clear? This line is clear. Line number 43 is clear to everyone. Please tell me. Then I'll proceed further with that. Is this point clear to everyone? Till this point, everyone is clear. If you have no node in the linked list, or if you just have only one node in the linked list, then you can simply return the root itself, right? Because see, if you will see here, like you would think, see, if you have no node, then that is fine. But if you have just one node, let's say this node looks like this, or let's say it looks like this, okay. Obviously, every node is sorted also, so it looks like this. Then you will directly return this node. So indirectly, you will return this whole linked list, single linked list, right? Is that clear? If there's only one node, let's say this is the root, there's only one node, right? There's only this node, right? So it has some bottom and also it is already sorted, so you will just return this, right? That is the case. Now other than this, what will you do, right? So there are two things that you need to keep in mind, right? Okay, there are Asthar Tripathi is also there, okay. So see, in this case you need to do two things, right? Can I say that, like, you need to do two things, right? The first thing is that you need to do two things. You need to flatten the linked list. Now what do I mean by flatten? First of all, what do I mean by flatten and what do I mean by merge? There are two different things, right? So see, if you will see here, right? If you will see here, like we are merging the linked list one by one. How are we merging them, right? Let's say that if I take this example, one is there, okay, then three is there, okay. Let's say this is something like four. Let's say this is something like seven. Let's say this is something like five. Okay. Now, if I'm starting, right? So if let's say I'm starting, so what is actually happening there, right? What is actually happening there, right? So I'm assuming one thing, right? I'm assuming one thing. Like, what is that one thing that I'm assuming here? I'm assuming that, let's say this is the current root. Okay, let's say this is the current root, and this is the roots next. Okay, this is the root next, right? So I'm assuming, what am I assuming here, right, guys? See, I'm assuming that, okay, suppose that all this part that is there, right, all this part after, from the root next, right? Because this is the root next, okay. So root next means that after root next, everything that is there, right? So basically, if there was this part, hold this part, right, all the rest of the linked list that is there, that is what root next indicates. Okay, so I'm assuming that this particular root next is, like, this particular part has already been flattened, okay. I'm saying that, okay, this particular part is flattened, okay. Then this particular region is there, okay. So I need to merge. What do I need to merge? This particular root is there, okay. So this particular very starting part is there, and rest of the linked list is already flattened. I'm assuming that starting from the root next. So if I say root next, so everything after the root next is already flattened, okay. So if this is the starting, okay, this is the start, just the start part, okay. This is just the starting part, very starting front part, and this is the part after the linked list that is flattened, right? So what I will do is I need to merge, okay. The idea is that I need to merge this particular root part, okay, this particular starting part with the rest of the linked list. Is that clear to everyone? Is that clear to everyone? Please tell me, guys. Astha, is that clear to you? Balaji, is that clear to you? Other people, are you clear with this thing? Please let me know, guys. Is everyone clear with this idea? If you're clear, please give me a plus one in the chat. Right? Are you clear with this thing? That I need. Let's assume this for a second. Okay, that the rest of the linked list is also there. Let's say there's this rest of the linked list starting from the roots next. Okay, so I need to do what? I need to flatten that part. Okay, let's say once I've flattened that part. So what does that mean? Right? What does that mean? So basically, if let's say one is there. Okay, so basically I'm assuming that let's say if the linked list looks like what? Just give me a second. One is there. Obviously three is there. Okay, then let's say 4 is there, then let us say that 7 is also there. Okay, let's say 5 is also there. All right, if this is how we have, like if this is what the linked list looks like currently, right? So in this particular case, if this is how the linked list is looking like, right? So I'm assuming that, okay, if this is the roots next, okay, so this particular part must have already got flattened. Okay, I'm assuming that, okay, this particular part must have already got flattened. So let us assume that it has already got flattened. Okay, somehow using recursion it has already gone flattened, right? So this is the flatten function, right? This is the flatten function. So for a second, like basically this is the flatten function that is passed. So let us assume that this much part is already flattened. Okay, so like what will happen? Right, what will happen? So see, basically let us assume that that much part is already merged and flattened. Right, so this much part. Right, so let's assume that, okay, this part is what, 4, 5, 7. Let us assume this, and let's say this is 1, 3. Okay, now if you are having this part, right, so this is what, this is nothing but the root. Okay, and this is indicated by the root next, right guys? So now, like, are you getting this point? Are you getting this point? Right, this is the next part, this is the rest of the part. If let's say if I apply this flatten function, because this flatten function will overall flatten the linked list, right? This flatten function is overall going to do what? It will flatten the linked list. So what I will do is, I need what? I need the rest of the linked list. Let's say the rest of the linked list look like this, right? After the roots next, rest of the linked list looks like this. So my, please write flat in the chat. Okay, please write flat in the chat. My task is to flatten the rest of the linked list such that I can merge it with the starting part, right? With the starting root part. Is that clear to everyone? Is that clear to everyone? My task is that I want to flatten the rest of the linked list such that I can merge, right, the rest of the flattened part with the root part. Is that clear? So that is what I want to do as a possibility. Is that clear? Is the idea clear to everyone? That is what I want to do. Rishit is clear with this. Okay, what about Asta? What about Naikaj? What about other people? Are other people also clear? If you are clear till this point, please hit the like button. If you're clear till this point, please hit the like button. Okay. Just as an acknowledgement, if you're clear till this point. Is everyone clear till this point? That is what I'm expecting, right? So let's say, let's see this, right? Let's see this. So let's say if I have one, okay, then I have three here. Okay, this is what is indicated by the root. Okay. Now rest of the part looks like what? Let's say the rest of the part is already flattened, so that is nothing but 4. Let's say this is 5. Let's say this is nothing but 7. Okay. So rest of the parts look something like, okay. So this is nothing but the roots next. Okay, and this is nothing but the root. Okay, so what will I do? I will merge. Please write this thing. Is that clear? I will write a merge function for merging the root part. Okay, basically this particular segment. Okay, this particular segment with the flattened part of the rest of the linked list. So basically, first of all, I will want the flattening of the rest of the linked list starting from the roots next. Is this point clear? Please give me a plus one again. Then I'll proceed further. Okay, please give me a plus one again. If this point is clear, is this clear? It's very basic, to be honest. Is it clear to everyone till this point? If you're clear, you can hit the like button, guys. Then I can proceed further as well. Okay, then I'll proceed further. This particular point is clear. Like, this is what has been written here, right? So in the end, you are returning what? You are returning the merge. Okay, you are returning the merge of the root and the flattening of the roots next. Okay, so obviously indirectly this recursion will keep on doing, right? So basically you are like, see, write once, use anywhere. Please write RECOP in the chat. Na? This is what recursion is all about. Just write it once, write the logic once, and use it every time for yourself. Is that clear? Write it once and use it every time. Like, use it as many times as you want, right? Just keep on using it. If you are repeating the same process, so write the code once and just keep on using it. Please write recursion OP in the chat, and then obviously I'll proceed further, and hit the like button as well if you're clear with this point. I have tried to decrease the mind complexity of this problem a lot as of now, right? So now please write merge in the chat. Right now my main focus will be on the merge function. Please write merge in the chat. Okay guys, please write merge in the chat. The overall function was flattened. Okay, the overall function was flattened. So basically, if I have to flatten, so I will do what? I will say that, okay, let's say that this flatten function is working. So I'll flatten the rest of the linked list from the next node. I'll flatten it, and then I'll merge it with the current root. That is what we are thinking about, right? I hope that it makes a lot of sense, right? So please write merge in the chat. Right now my logic is that I need to implement the merge, uh, this thing. I need to implement the merge function, right, recursively. Is that clear? Because I will be doing the merging again and again, so it will be again recursion. Please write merge in the chat. Merge will be again recursive in nature, because if this linked list is there, like this is the first part and this is the second part, right? So I want to do what? I want to merge this particular part with this part. So I will repetitively keep on doing it, right? So because ultimately the linked list would look like 1, 3, 4, 5, 7 and all that stuff. So I'll repetitively keep on doing it. Please write merge in the chat, guys, and then we will proceed further. Is it clear to everyone till this point? I hope it makes some sense to all of you. Does it make some sense, guys? Okay. So that is what I'm trying to do, right? So let me remove this much part from here. All right. Okay. So this is what we'll do, right? So see, this part is there, right? So this is the part. Okay. This is the roots next. Okay. And this is the root part, right? So I'll write a merge function for it. Okay. Great. So see, what will I do here? Again, like, can I say that I'll have a resultant, right? I'll have a node start resultant. Okay, so I'll have a resultant list out of it. Now what will the resultant look like? See, it's, have you heard about merging two sorted arrays, merging two sorted linked lists and stuff? Yes. So see, basically what am I passing? Like, if you will see, so can I say this thing, guys? Can I say this thing if I'll change the color of this pen, right? So can I say one thing here, that if I'll remove this segment and this segment, right? So can I say that? Can I say that this much segment is the list one, right? This is the starting of the list one, and this is list two. Please write yes in the chat. What do you think? What do you think, guys? Is that clear to everyone? Please write L1 and L2 in the chat. This is list one. This is list two. Basically, indirectly, I need to merge the list one with the list two, right? List one is what? List one is nothing but the flatten part for the roots next. Okay. So I am thinking that, okay, rest of the linked list that was overall that was there, that is now flattened with the help of the flatten function, right? Now, if this is the list two that I am containing, right? So I'm expecting that, okay, the list two and the list one, that is like, that looks like this linked list, okay, and the list one that looks like this linked list. So I want to merge the list one with list two. Please write L1, L2 in the chat if you're clear with this thing, and please give me a +1 if you're clear with till this particular point. Is everyone clear with this particular point? Please let me know. Okay. Is everyone clear till this particular point? Okay. Now, again, the answer is very simple to this, right? I'll have a resultant node. Okay. I'll have a resultant node. So I'll start building a resultant linked list. Okay. Now, I'll not take any extra data in that. Okay. So see, now L1 is pointing here. Okay. L2 is pointing here. Which one is minimum? You will take the minimum. Please write MI in the chat. You will take the minimum out of them, right? If L1 data is lesser, right? See, if L1 data is lesser than L2 data, right? If L1 data is lesser than L2 data, guys, then you will take L1. Please write L1 in the chat, right? If L1 data is lesser than L2 data, then you will take L1. So you'll take this node L1, okay? And then you will say that okay, like basically you'll say that, okay, result is equal to L1, let's say, okay, something of this kind, right? You will say this thing, right? So see, also one more thing, like I'll discuss that at the end, right? So basically you will do this, result is equal to L1, let's say, okay, this particular thing, resultant list is equal to L1, list one, and then you will say that, okay, result bottom is equal to merge list, this option. So basically what you will do, if you're going to the bottom of this linked list, right? So you will say that what, you will say that, okay, you will call the merge function now, okay? And if you're moving in the first linked list, so please write bottom in the chat. You will be moving in the bottom now. So you'll say that, okay, L1, now you will pass the next node as the L1 bottom in the merge function, and you'll pass this L2. Is that clear to everyone? This is what we are doing, right? This is what we are doing. We have the result as the list one. If the list one data is lesser than the list two data, so I have a resultant linked list. If the list one data is lesser than the list two data, then I'll have the list one node, okay? And then I'll move to the, like, then I'll say that, okay, in this resultant linked list, right? In this resultant linked list, since I'm returning this final linked list, right? So in to its bottom, I want to attach everything, right? In the end, I want a single, I want to return a single linked list kind of thing, right? So in that case, like, what will I do? I'll say that, okay, for this resultant linked list, to its bottom, okay, I'll add the rest of the result. I'll add the rest of the result. Okay. Is that clear? This is what I'm expecting to do. So basically, that is why I'm passing the list one bottom and I'm passing the list two, right? So you can understand one thing, like if you have flattened this linked list now, so obviously the second linked list will also look something like this, okay? The second linked list will also look something like this. Let's say 5, 7, whatever, something of this kind, okay? So this will be the list one, list two, right? So ultimately, you will be returning it like this. Is that clear? Now, if it happens that otherwise, if the list two later, do we have to add bottom? Would that be adding to the next work? No, adding to the next will not work, because I think they want it, they want you to return everything in bottom format, I think, in the end, right? So see, uh, flatten the linked list printed using the bottom. Yeah, they are saying the flatten the linked list using the bottom pointer. So here they are expecting that you will flatten the linked list using the bottom pointer. Okay. So basically, what will happen? Let's say if you had, like, this linked list was 1 3, right? That was the original linked list, and the other linked list would look something like this. Let's say, okay, I thought that it was next, but let's say if it is pointer, right? So this is the case. This is the list two that you are having. Okay, this is the list one that you are having, right? And now you will be here, you will be here, right? So initially the result will be what? Resultant node will be nothing but the node one. Okay, now L1 will move here, right? L1 will move to the bottom if you take this, right? Then I'll say that, okay, now I'll add the result, like results bottom will get updated, no, results bottom will get updated to the recursive result of the merge, right? Is that clear? So that is why I'm passing merge L1 bottom list 2, right? Otherwise, if the second is having lesser data, so let's assume a result like this. Let's say if I have something like this, let's say if I have one, like if I have 5 here, then I have 4 here, okay, then I have, let's say, 7 here, and I have something like 6 here, and let's say if I have 8 here or something like that, okay, let's say this is the L1, okay, let's say this is the L2. Then in that case, the final resultant linked list will first of all contain 4, and then for 4 bottom I'll add, so then L2 will move here, right? So then otherwise I'll move to the bottom of the L2 in the merge function. Is that clear to everyone? Is this point clear to everyone? Please hit the like button, guys, if you're clear with this. Is everyone clear with this point? I hope that it makes a lot of sense. So that is how I'll keep on doing it recursively. Okay, just give me a second. So this is the thing that I'll keep on doing recursively. Is that clear, guys? Is that clear? And once it is built, so I'll return this resultant linked list. I hope it makes a lot of sense in recursion. Is it clear to everyone, guys? Please let me know if it is clear. And sorry, if I forgot that the linked list was next. Like it was based on bottom. Is this problem clear to everyone? I am not sure why we are streaming at night. I don't know. So is it clear to everyone? Basically, we coders love dark mode, right? Okay. So is this problem clear, guys? That is what we are doing. So basically, we are merging. We are merging based on the bottom, and then we have this flatten function as well. I hope that it's pretty much clear to everyone, right, guys? Is it clear? If you are clear with this question, please write clear in the chat. So basically, the rest of the linked list that is flattened, it is based on the bottom, and then this part is there. Okay, I'll provide the solution as well. All right. So let me copy it. I forgot that it was based on next pointer. Sorry. Okay. Sorry, it was based on the bottom pointer, not the next one. Although I solved it in the night only. Okay, Asta Tripasi says yes. Okay. So that is what we are doing. And overall, we'll be iterating. In the worst case, we'll be iterating through the n nodes, right? So that, like, basically, in the worst case, n cross m complexity will be there, where n is the number of total nodes that you'll be having, and m is the nodes for every linked list. So basically, m cross n kind of, it's a square. It's a matrix. Like it's a, like you have this much nodes, and for every node you can go till this much depth, right? So basically, it is nothing but the length into breadth kind of scenario, right? Are you clear with this thing, guys? Let's say if there are there are two nodes here, right? Two nodes are here, and every node has a depth of two. Like, sorry, every node has a depth of three. So total six nodes might be there in the worst case, right? Although here are five nodes, right? So that is nothing but a, that is the length into breadth. Like it's nothing but the length, the number of nodes in the next pointer, into the bottom breadth. So that is nothing but the bottom pointer. So but number of bottom pointers in the worst case, maximum number of bottom pointers. So that's nothing but L into B. You can say N into M kind of thing. Okay. Kudos to you, sir. You took 2 hours of live session and now problem of the day. Yeah, but I enjoyed it a lot. Okay, I also, now I'm more in love with this problem as well. Okay, thanks a lot, Vanchika. Okay, so this is what we have done. This was the problem of the day, everyone. And the solution obviously gets accepted. Basically, if the root is null, or if there is only one node, then you will simply return the root. Otherwise, you will first of all flatten the rest of the linked list, and then you will merge it with the this part, with the first bottom, like first part. Okay, so basically if rest of the linked list is there, as I said, if the rest of the linked list is there, right, if let's say that rest of the, like if the linked list look like this, let's say 1, let's say 3, let's say 5, whatever, and the rest of the linked list looks like 5, 7, let's say 8, okay, let's say this is 10, let's say this is 50, okay, right, let's say this is something like 51, let's say this is 100 or something, right? So you are assuming that, okay, like if this is the roots next, okay, if this is the root next, so basically what will happen, the this much part, okay, you will flatten it. Please write flatten in the chat again, okay. You will flatten the roots next, okay, you will flatten the roots next. So basically you'll flatten whole of this part, okay, and then what you will do is, if this is the root, okay, so obviously this much, like in that case, this is how the linked list will look like. Basically this part will be there, and the rest of the flattened linked list now will look like this, let's say something of this kind, okay, something of this kind. So this is after flattening, right, this is after flattening. So basically this is nothing but flatten of roots next. This is nothing but flatten of roots next, right? So let's say this is nothing but L2, right? uh, and this is L1, right? This is nothing but the root. So in the end, what you will do is you'll merge the list one with the list two, right? So that's what we are going to do. And obviously you have to move to the bottom of them every time, right? So whichever is lesser. So as I said, like let's say if one of the list gets exhausted, then you'll directly return the second list after that. Okay. If the second list gets exhausted, then you'll return the first list. Are you clear with this thing, guys? Let's say that if you have something of this kind, give me a second, I'll show you here as well, right? Let's say if you have a some, like please hit the like button, guys, if you are clear till this point. I can see a lot of people are watching us, have put a lot of effort in this question as well, so you can hit the like button if you have enjoyed till this point, right? Let's say the link list is like this, 1 and 2 is there, okay, and let's say this link list is like 3, let's say this is 4, okay, let's say this is 5, right? So then you will use this pointer, so 1 will be there, then after that sorry, one's next will be what, 2, okay, so 2 will be there, then after that you will move to the next, so this will be nothing but null, right? So L1 will move here and L2 is still here, right? So in that case, you will attach the rest of the linked list, right? So that is why you are returning the L2. So that is why 3, 4, 5 will already get attached, right? If one of the linked list gets exhausted, then you will simply have the return the other linked list, right? Similarly, if the second linked list gets exhausted, then you'll return the first linked list, right? Otherwise, you'll declare the root start result, okay? And if the result, if the data of the first linked list is lesser than the data of the second linked list, then you will say that, okay, result is equal to list one, okay, and then you'll say that, okay, result bottom, you will have this result as list one, and then bottom will get updated with the next part, with the rest of the part. Is that clear? And same thing will follow for the second list two. If list two data is lesser, so you will have it, and then you will create the result for the next bottom part, and the recursion will return you that, and in the end you will return the final result. Is that clear to everyone? Please tell me, guys. Is this problem clear to everyone? I hope it is clear to everyone. Is this problem clear to everyone? Please hit the like button if you're clear with this. We can go with the iterative approach. Yes, you can go with the iterative approach as well. Recursion is also a good approach, and I had a little bit of less time, so that is why I used this approach. Thanks a lot, Vanchika. I did live streaming on that platform, Resolution Days, GFG main YouTube channel, and then now we are doing POD. Okay, so everyone understood this? Please give me a +1 if you understood all the problems, right? Quick recap. I think the video is very long. I have already done the recap, so you can watch the recordings at 2x. Okay. So now for one last time, I'm asking you this thing. Okay. So please make sure to hit the like button. Okay. Please make sure to hit like button. Please make sure to hit like. Okay. Let's see if we can reach somewhere around 23 likes or not. Let's see. I can see a lot of people are watching us. Please hit the like button, guys, and then I'll end this stream as well. Okay. So let's see if we can reach at least 20 likes or not. At least 20 likes before I end. Two more likes. Let's see. Okay. All right. Okay. So with that being said, thanks a lot everyone for joining. Make sure to hit the like button. Make sure to solve the problem of the days regularly. With that being said, thank you everyone for joining. I'll see you in the next week on Monday with another problem of the day. Till then, good night. Take care and keep solving the problem of the days. Thank you everyone and bye. Bye Asta. Bye Naikach. Bye everyone. and make sure to hit the like button. Okay. Bye everyone. Good night.